The higher of the two voltage levels is symbolized as 0 and lower as 1, then it will be said as negative logic gate. So input and output behavior of a gate is generally represented using the truth table. So now we will start with different types of gates. But before starting with not gate, I would like to share this. Here you can see this is a buffer. Can you see? This is a buffer.
एक्सपेक्टेड में घुस गया है क्या?
So buffer, that is, if we have
एक
a
तो मैं
value
घुसा हूँ।
as x
हाँ
अरे
देखो
ना
input,
शायद
यार,
ये आया है।
then the
अरे
output
ना
will
यार,
be
देना।
same as x. So why we will use this buffer? Just for
कितना है
the
इसमें?
same result, why we will use this buffer? So it is just for some time the voltage or the voltage has to be dropped, and just for time, suppose we want to show the same output for 2 seconds, for 5 seconds, then we have to use buffer for the voltage drop. But the actually output is same. Here you can see in this table, that is, if x value of x is 0, then the value of y will also be 0, and value of x is 1, then the value of y will also be 1. So we are getting the same output as the input. So this is buffer. There is no bubble sign here. But in case of NOT gate, that is not, that is the complemented output. So if the input is x, then we will get the output y equals to x bar. That is the complement output of the input. So if value of x is 0, then the output y will be 1, and value of x is equal to 1, then the value of output will be 0. So this is NOT gate. Here we are using this symbol, that is a triangle, and before that there is a bubble sign is here. In case of OR gate, OR means the addition. That is, if we are taking two input values x and y, then the output z equals to x plus y. That is, we are adding the two inputs, but it's binary addition. That is, if 1 plus 0, so the output will be 1, and if 1 plus 1, the output will be 1, and 0 plus 0, that is 0. So here is the table for the different input combinations of two variables. You see that if we have two variables x and y, then the combination of different inputs will be 2 to the power 2, that is 4. That is either 0 0 or 0 1 or 1 0 or 1 1. So these are the input combinations, and the output we have this z. That means depending on this symbol, we see that x and y are the inputs, and z, that is x plus y, the value of x plus y, that is, we are saying z. So 0 plus 0, it is 0, and 0 plus 1, it is 1, 1 plus 0, 1, and 1 plus 1, 1. So this is the OR gate. Now in AND gate, it is just x into y. This is the dot symbol, that is multiplication, x into y, and we are also having two inputs here, and the z output equals to
स्टार्ट नहीं करने का है, 21 नंबर में उसको किक
z
करने का है,
output
ठीक है?
equals to
नहीं नहीं
x
हो गया
plus,
हो गया
अरे
आपने
वो
sorry,
सेट
हट
x
करना
गया
अच्छा
into
हट
हो गया,
गया।
y.
हो गया, किक कर दे,
So
किक मतलब
it
स्टार्ट
is
कर दे, स्टार्ट
x
कर दे।
into y, that is 0 into 0 0, 0 into 1 1, 1 into 0 0, and 1 into 1 1.
अरे भाई
So
ऐप डाउनलोड क्यों नहीं कर रहे हो?
here also you can see the different logic gates. that and or. Now it is NAND, NOR and XOR. See this slide. Now these are the other logic gates. But if we say basic logic gates, so basic logic gates are these. And these are the other logic gates, that is NAND and NOR. These are the universal, this is also called the universal gate, NAND and NOR. And there are two other gates, XOR and XNOR. So now NAND gate, that is complemented AND. So if we are getting the output from a AND gate x into y, then in NAND gate we will get x into y complement. So here you can see that x dot y, and there is a bar or complement sign is over here. So it is the complemented output of x into y, that is complement of AND gate. So it is quite like AND gate, but there is a bubble sign here. So it is called NAND gate. This is the AND gate, and if we put a bubble before AND gate, then it is shows us this symbol. This is the symbol of NAND gate. So here x and y are the inputs and z is the output. You see, these are the input combinations are same, as we have only two inputs x and y. So the input combinations will be these four combinations. Zero, either it would be 0 0 or 0 1 or 1 0 or 1 1, and the output, that is 1, suppose first one, that is 0 0. So value of x is 0, value of y is 0. So 0 into 0, that is 0. 0 complement. Complement of 0 is 1. So this is 1. Now 0 and 1. So x having value 0 and y having value 1. So x into 1, that is 0 into 1, we are having 0. So 0 complement, that is also 1. Now the value of x is 1 and value of y is 0. So now if we do the AND operation, then the output is 1 into 0, that is 0. And complement of 0 is also again 1. Now if we are having this 1 1 value for x and y, so 1 into 1, that is 1. Complement of 1 is 0. So we are having this 0 as z output. So this is the NAND operation, that is complement of AND. Now we are having this NOR gate. NOR gate, that means x plus y complement, that is complement of OR gate. So this is a symbol of OR gate, but before that we are seeing that there is a bubble. It's a bubble. So the bubble always likes the inverted output of that gate. So if we are having these inputs x and y, and this is a OR symbol, so x plus y is the operation doing here, and before that there is a bubble, so there will be a bar on this operation, that is x plus y bar, that is also called complement. X plus y complement or bar. So z equals to, we are having x plus y bar, and having the same input combinations, that is 4 different input combinations, we are getting the output. For 0 0, it is 0 plus 0, and complement, that is 1. Now 0 and 1, so 0 plus 1 is 1. 1 complement is 0 0. 1 and 0, x value is 1 and y value is 0. So 1 plus 0 and that complement again. So
क्या बातें हो
we
रही
are
हैं?
having this 0
बहुत
output,
मुश्किल है
and now x and y both are
और
having
वीडियो
second.
डाल
1 values. So
1
1 plus
second,
1,
brothers.
we know that
Give
using
me
the
1 minute.
binary addition, it is
हाँ बोलो
1 plus 1, that
बोलो
1,
हाँ
not 2.
बोलो
So
रे बाबा.
1
हो
complement, that
गए.
is again it is 0. So this is
2
the
8
output
5 8
of NOR gate. This is the truth table. This
5
is
6
also
2
called the truth table of NOR gate.
2
Now the X are
233 में पास दे रहा है
operation.
भाई, तू अब डाल है।
X OR operation. This is X plus Y XOR, that is A bar plus B bar. See here. So this is the XOR. So, and again I want to say that this NOT gate having the IC number, for NOT gate we are having the IC number 7404. I think you have to write in your copy that NOT gate having the IC number, that is integrated circuit. There are different types of numbering for different gates operation. So for NOT operation, we have a inverted or complement output IC, that is IC NOT gate IC, and its number is 7404. And for this is the 7404 IC. All ICs are quite same, but NOT gate IC is quite different from the other ICs because the direction of the gates are different. Here the input is 1 and the output we are getting from pin number 2. This is a 14 pin IC and there is a notch before the IC. If we put the IC in the left direction, then we can see there is the notch in the left side, and then we will start with the downward spin, that starting from 1 it is up to 7, and toward the upward direction it is 8, 9, 10, 11, 12, 13 and 14. 14 is used for VCC, that is current supply, and for 7 number pin is used for ground, that is GND, ground. And 1 is input of the NOT gate and 2 is the output of the NOT gate. Again, there are 6. You can see that there are 6 different NOT gates. So if we put our power supply in this number 3 pin, then we will get the output, corresponding output of that power supply in the pin number 4. So we have to make a circuit in our lab session for different gates, logic gates, using register, using LED and the power supply, and we have to follow the truth table if we are getting the output as the truth table or not. So this is just a IC diagram of NOT gate. Here is the AND gate, this is the AND truth table, and AND operation is here, that is A into B. As I told you before, that is X into Y, it is same A and B, A into B. So this is the AND operation, that is multiplication operation. We are doing the multiplication operation here using the AND. This is the light or LEDs, and these are the switch. But we have to design a separate. This is the OR gate. For OR gate, this is the symbol, this is the truth table, this is the Boolean expression, that is A plus B operation is doing here. And write down for OR gate, we are using 7432. Here it is not shown, but I will give you different note of the IC numbers, or you will get from your book that OR gate having the IC number 7432. 7432 for OR gate, and AND gate for AND gate 7408. And for NOT gate, as I told you before, 7404. This is the exclusive OR or XOR gate. So I told you that exclusive OR gate output equal to 1 when the two inputs are exclusively different. Here you can see this in this truth table that when A and B, both the inputs are different, that is 0, value of A is 0 and value of A is 1. And value of A is 1 here and value of B is 0. So these are the different input combinations. For these different input combinations or exclusively different input combinations, we are getting the output as 1. But if we have same input values, that is both A and B having the input value 0 or both A and B having the input values 1, then we will get the output as logic 0, that is power of 0. So our LED will not glow. But if there are different input combinations, then we will get the our LED will glow or we will get the positive output, that is 1. So in this reason, this is known as inequality gate. Inequality gate. Remember the schematic symbol and the truth table. Here it is shown. So this is the operation XOR operation and the symbol is like this. There is a circle and between this there is a plus symbol. So exclusively OR. Now this is the XNOR. So you all know that NOR gate, that is the complemented output of OR gate. So what we are getting as in the OR gate, okay, let me show you again. This is the NOR gate, and if the output of OR gate was X plus Y, then we get as output even from the NOR gate as X plus Y complement. But in XNOR, we are getting that X plus Y, X XOR Y whole complement. That is X XOR Y. This is the symbol of XOR. This is the symbol of XOR, and there is a complement over here. So exclusively NOR gate is XOR gate followed by an inverter. So this is the XOR part, and then we can see here is a bubble, that is an inverter. So exclusive the bubble or inverted output after an XOR operation. So XNOR can be shown as a point between a circle. This is the symbol or Boolean expression. This is the logic diagram symbol, and here is the truth table. So you can see in this truth table that if the values of inputs are same, then it is 1. And if the values of the different input A and B are different, that is exclusively different, then the output is 0. This is the NAND gate. Now, hello. These are the symbols. Okay. Now, I want to start the universal gates. Oh, I think I forgot to tell you the IC number of XNOR gate. The IC number of XNOR gate is 7486 and you have to keep it in mind that all the IC numbers you have to remember before doing the lab. So universal gates. Universal gates we generally call the NAND and NOR gates are called universal gates, as we can generate different types of logic gates, that is all the basic logic gates using this NAND and NOR. And why these are universal gate? Because these are um, uh, it is very easy to design the different digital basic gate circuits or logic gate circuits using NAND or NOR, and it is cheaper, and it is very cheaper. That's why the fabrication process is easy, and also it is low cost. So AND or NOT gates and the other logic gates like NAND or NOR are also used in this digital circuit. The NOT circuit, that is the inverters and the logic sense of the binary signal. The same a small circle, that is bubble output of the symbol NOT gate, is called the inverted output. This is the bubble. So now the NAND gate is the NAND operation, as I have already shown you, and this is the NOR operation that is also shown. Now the universal gates. The NAND and NOR, as I told you before, that universal gate is a gate which can implement any Boolean function without need to use any other gate type. So if you have NAND gate, you can design any Boolean function using that NAND gate. Or if you have NOR gate, only different number of NOR gate, then you can design different Boolean functions using only the NOR gate. So this is advantageous since NAND and NOR gates are economical. This is very economical and easy to fabricate, as I told you, that easy to fabricate, and all the basic gates used in the IC digital logic families. In fact, AND gate is typically implemented as NAND gate followed by an inverter NOT. How it is possible? Let us see this. So this is the NAND operation. So we are having an input A, and there is a bubble. So this is the NAND gate, and if we use this NAND gate, if we want to use this NAND gate as AND operation, for doing AND operation, then we just have to attach these two inputs and pass this A input, because in AND gate we know there was only one input X, and now there was two inputs X and Y, but if we multiply, if we attach these two inputs, then we will get the complemented output, that is A bar. So here we are getting that not operation, we are getting that A bar. We are using NAND gate, but we are getting the NOT output, that is the inverted output of this A input, that is A. So it is its operation is not of, and that is AND operation is A into B, and not of AND, so it is complement. So this is A into A whole bar, that is A bar. So it is, if we say that A is the input, so we will get A bar as the output. So this is the NAND gate using, sorry, NOT operation using NAND gate. In this way, one NAND input pin is connected to input signal A, while all other input pins are connected to logic 1, and the output will be A complement, that is A bar. So implementing AND gate using NAND gate. Look at this, this is very important. We are having two NAND gates. So here we are getting that A dot B complement, as you see, A dot B complement. So this is the NOT operation, just A dot B complement. Again, if we use another NAND gate and by passing this AB input to all the two inputs of this gate, then we will get this again inverter operation will be doing here, and all the bars or the complements will remove, and we get A dot B, that is the AND operation. A dot B, that is A and B, A into B. So this is the AND operation. So this is the AND operation logic using NAND. Using NAND, because NAND is the universal gate. We can design any other gate using NAND and NOT. So here just only the NAND operation. So this is the AND operation. Now it is the OR operation. For doing the OR operation, we are having three NAND gates there. This is the A input, and A is passing through both the inputs. So we are getting A bar or the complemented output here. So A bar is the output. Here we are again passing the B input, and we are getting the B complement or B bar output. And again we are passing this A bar and B bar as input to this third gate of NAND. Then we are getting that A bar dot B bar and whole complement. Whole complement. So we are getting this A plus B. This is the final output, and A plus B is also the output of the OR gate. So we are getting that A plus B, that is the OR output from these three NAND gates. So this is the OR implementation of logic gates using NAND gate. We are not using here the 7432, that is OR IC. We are only using the NAND gate, that is 7400, as the as the IC. Thus the NAND gate is the universal gate, since it can implement the AND, OR and NOT function. The NAND gate is universal gate. So now we have to prove NOR gate. NOR is a universal gate or not. So again we have to show this AND or NOT operations using this NOR gate. Here the NOR input pins are connected to the input signal A, and this gives an output A complement. So this is the complemented OR, that is NOR symbol is here, and if we input A, then we will get the complemented output, that is A plus A whole bar. So it is a bar. So it is, as we see here, the output is like NOT gate, and this is a complement or like NOT gate. Now NOR gate as OR gate. NOR gate as OR gate, here we can see that A and B are the inputs and we are getting A plus B whole bar. So the output is A plus B. Final output is A plus B, and A plus B is the output of also OR gate. So it is like OR gate. Two bubbles. So complement of complement, that is there is no complement, so output is A plus B. And now we have to implement the AND gate using NOR gate. So we have to use three NOR gates here, that is number 1, number 2 and number 3. So first one we are having the output as A complement, second one we are getting the output as B complement, and in third one A complement plus B complement and whole complement. So it is A dot B, that is A multiply B, A into B. So it is the output of AND gate. So we can see that NOR gate can also be used as universal gate. So we can design any type of gate using this NAND and NOR. It is not required now. There it is same. Before starting Boolean algebra, I want to start it from tomorrow, but these are the ICs. Okay, Boolean algebra. Before starting Boolean algebra, you have to practice these gates and the two tables of the gates. Then we will start from tomorrow the Boolean algebra. Have you practiced that the assignment that I have given to you? This is the IC. See here, This is the IC of NOR gate, NAND gate, that is 7400, and here you can see that 14 pin is also here, but we are getting only 4 number of gates inside it. Only 4 number of gates, not like NOT gate. Before this picture, I have shown you the IC diagram of NOT gate. Here there were 6 gates, but here you will have only 4 gates. That is 1, 2 as the input of the NAND gate, and 3 as the output. We will get the output from number 3 pin, and 4, 5 are the inputs, and 6 is the output, and 7 is ground. Now here 8 is the output, and 9 and 10 are the inputs, and 11 is the output, and 13 and 12 are the inputs. So uh, if we think that 13 is A and 12 is B, so if we input A and B following the truth table, then we will get the Z output or the F output from this 11 number pin. So we have to check using only one gate for the logic, the truth table verification of different logic gates in the lab. But if we have to design the using this NAND gate as universal gate, then several ICs can be required. So this is the IC diagram of 7400. Here are the IC diagrams of 7404, that is NOT gate, 7408, that is the AND gate IC, 7402, that is NOR gate. This is the NOR symbol here. This is the AND symbol, and this is the NOT symbol. Here you can see that we have six number of NOT gates, that is inverters. But here we have only 4 number of gates and gates. Here also we have 4 number of NOR gates. But there is a difference with all ICs with NOR IC. 7402 is totally different. 7404, you have to remind these 3 IC diagrams. 7404, it is different. 7402, it is completely different, and 7408 is same as 7400. All the ICs are same except 7404 and 7402. 7402, here you can see that 2 and 3 are the inputs. Here 1 and 2 input and 3 output in 7408. But in case of 7402, 2 and 3 are the inputs, and we will get output from 1. It is also same, that is 6 and 5 are the inputs and 4 is the output. And on the opposite side, 8 and 9 are the inputs and 10 is the output. And 11, 12 are the inputs and 13 is the output. So you can see that 7402 is completely different from the other ICs. And its direction is also different. Also it is in opposite direction. The notch is upward, but its direction is also towards the notch. But in 7408, it is opposite side of the notch. The direction is opposite side of the notch. But in every IC, the 14 number pin is used for VCC, that is current supply, and number 7 is used for ground. Is it okay? It is also opposite direction of the notch, that is 7400. Is it okay? Can you understand? Okay, yes, ma'am. So I think it is enough for today. First, you have to practice this. I will send you a new note on this topic with the IC diagrams also. You have to go through this note first, and then on the next week, I will take a Viva exam regarding the gates. Okay. So Sagurde, do you understand? Are you there?
Yes, ma'am.
Yes, ma'am.
Do you understand the IC diagram?
Yes.
Yes, ma'am. Little bit confusion is there.
Okay, I will send you a new note.
Okay,
And
ma'am.
confusion is regarding what? Universal gate or in every gate? The
Ma'am,
operations are very simple. In NOT gate, we have to complement.
yes,
Only
ma'am.
two inputs combinations are there, zero, either 0 or 1. Output is also same, either 0 or 1. Only two combinations are there because these are handling the binary system. And using that inverter output, we will get the complemented output. And if we use AND operation, then the multiplication operation is there, that is into operation, A into B. And in OR gate, we will add, just add. There is no difference or subtraction or any other operation, just into operation, complement operation, and addition operation. Three operations are there. So you have to go through the truth table and the universal gates, that is NAND and NOR as universal gate, their circuits, and the IC diagrams. Okay, so this
Okay, ma'am.
is
Yeah, ma'am. Okay, ma'am.
okay. Thank you for your patience hearing. Hope you are all
Thank you,
doing
ma'am.
well.
Thank you, ma'am.
Study
Thank you, ma'am.
first. Okay. See you tomorrow.
Thank you, ma'am.
And the last date for the assignment submission is Friday.
Yes, ma'am.
So practice and don't think about the marks. There is written 20 marks, but it is not sufficient. Don't think about the marks, only practice. But must submit before Friday. Okay?
Okay, ma'am. Okay,
Thank you.
ma'am.
So next, today you have class. Which class you have next? CR. Where are the girls? They are not responding. Okay. So take care. Bye.